Okay, so for problem number 4, we've got a RC circuit, and there's a lot of resistors here. So in this scenario, we are first looking at when the switch is open. And so right now it's actually just a resistor circuit. So we're going to treat it as a circuit with a bunch of resistors. We need to find the electric current in the battery, which is the total current. And so I'm going to redraw this circuit with just the resistors. And in this case, the 6 ohm and the 12 ohm are going to be in series with each other. So this is 3, 6, 6, and 12. Remember, redrawing the circuit is important because the switch is open. This whole branch is gone, and this is not a junction. Okay, so now we've got 2 in parallel. These 2 create 18, and then we've got, oh, actually this should be 9. We've got 18 and 9 in parallel. So 1 over 9 plus 1 over 18, and then we're going to take the reciprocal of that, which is equal to 1 over 3/18, which is equal to 6. And then the 6 ohm resistor is in series with this 3 ohm resistor, and that's going to give us 9 ohms. Okay, so once we find the equivalent resistance, then we can find the current because we know the total voltage of the battery, and current is equal to V divided by R, which is 36 divided by 9, and that gives us 4 amps. So that's our current through here, 4 amps. We know it's going to split because we've got a junction there. And we also want the current through resistor 12. So what I'm going to do is I'm going to analyze this scenario as 9 and 18 because I want the current through 12, which is this guy right here. And the voltage through 12. So if I can find the current through this branch, I will be able to get the current through 12. One thing we talked about in class is instead of doing Ohm's law, you can do these problems using proportions, and most of the time with AP questions, they're nice values, not decimals. So in this scenario, I can see that 18 ohms of resistance is double the 9 ohm. What that means is that my current is going to be half for the larger resistor than what it would be for the 9 ohm resistor. So I know that the current coming into the junction is 4 amps. I know that 18 is going to be half of 9, so if I divide it by 3 and I take 2/3 of the total, which is 4, that would give me the current through 9. And then if I wanted the current through 12, I would take 1/3 of the total, and that would be my answer for B. So this is 4/3 or 1.33 repeated for part B. So I've answered part B here. That's 1.3 amps or 4/3. I've answered 4A here. Oh, sorry. Both of those need to be moved up. Just gonna slide them up slightly. Okay, so now the last part is to determine the voltage drop. So we're going to do the voltage drop since I know that I've got 1.3 amps. Voltage is equal to IR, which is 1.3 times a resistance of 12. And if I multiply that together, actually, I'm going to rewrite this as 4/3 because that'll give me a nice value, and I get a voltage of 16 volts. Okay, so for case 2, the switch is closed. This is closed, and we want to know the charge on the capacitor. C equals Q over V, which means Q is equal to CV. I know the capacitance is 5 times 10 to the negative 6, which is microfarads, and I just need to find the voltage across the 5 microfarad capacitor. What I know is that in this loop right here, we have some voltage dissipated through the 3 ohm, some voltage dissipated through the 6 ohm before this capacitor can fill up with charge. And so what I can do is I can figure out what these 2 voltage drops are and take that remaining voltage out of the total 36 and plug that into my V. Or I can look for the voltage across the 12 ohm resistor. When I look at this junction, I can see that there are no other components in this branch out here, and so I know that whatever voltage drop I have through the 12 ohm resistor, I'm going to get the same voltage drop through the capacitor. You don't want to do this for the 9 volt. This is not going to be the same, and the reason why is because this voltage does not include the voltage drop through the 6 ohm resistor, and it's not going to actually be parallel or have the same voltage as the 12 and the 5. So let's figure out what the voltage drop is through the 12. We know that we solved for it. The voltage drop across the 12 ohm resistor is 16, and so I can just plug that in here because I know that they are the same. And when I plug that into the calculator, I get 0.00008 coulombs. Okay, last but not least, we want the energy stored in the capacitor. Energy is equal to 1/2 CV squared. I have the capacitance here, I have the voltage from here, and I can plug them in. The other option is to use 1/2 QV, which you already calculated the Q there. All of them are going to give you the same answer. So when I plug this in with 5 times 10 to the negative 6 and a voltage of 16 squared, I end up getting 0.00064 joules of energy. So that is for part E. I'm going to squeeze it in here so that it's clear because I know my work is not very neat. And then that's it.